Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of direct variation. This is standard A.2D in the great state of Texas, and we are using item number 42 off the 2021 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we just have a very simple statement. The value of y is directly proportional to the value of x. And so sometimes it will say directly proportional. Sometimes it might say varies directly. Either way, we are going to be using this formula right here, y equals kx. When it says directly proportional or varies directly, this y equals kx is called direct variation, and you should notice that it looks very similar to y equals mx plus b. Right, so in both situations, the y is going to be our dependent variable. So what the y is depends on the x and your constant there. So this is x stays the same, that's our independent variable. Now, even though we have different letters here, the K and the M, they both represent the same thing. We just use them because they're in two different formulas. One slope-intercept form, right? One is direct variation. So in our slope-intercept form, we're going to call it an M. But when we're using direct variation, we're just going to call it a K. But either one, they both represent our slope or our rate of change when we're dealing with it inside the direct variation. This k actually has a very special name. It's called a constant of proportionality. But they both represent that same thing. We're going to multiply that by our x to get our y. Now, what's the difference between these two? Well, it's that plus b. That's what sticks out on our slope-intercept form is the y-intercept. We don't have that on our direct variation. So when we are drawing a graph for direct variation, it is proportional, and the graph is going to go through the origin right through there. Whereas when we're drawing a graph here, if we have a y-intercept, it's not going to go through the origin. So graphically, you can see they're different as well. So how does that help us? Well, it's a pretty simple equation here. Y equals kx. They're going to give you the y and the x. They don't give you the k. So how do we find the constant? Well, we can derive it here. So just divide both sides by x, right? So when x is 35, y is 14. So that's going to be 14 over 3.5, not 35. That's going to equal my k. All right? So how many times does 3.5 go into 14? Well, if you double 3.5, you're going to get 7. If you double that, you're going to get 14. So it just equals 4. So that's my constant. Constant of proportionality is 4. So what is the value of y when x equals 28? Well, we plug it back in here, right? Y equals kx. Now that we have our constant of proportionality, we know we're looking for the value of y. X is 28, and k is 4. So it really, it's just 4 times 28. That's it. This whole thing is just 4 times 28. So that's 2, all right, 112. Now, this is a griddable response item in an Algebra 1. It's kind of an interesting one. So you've got a floating decimal point in Algebra 1. When you're gridding this in, you're going to get 7 different spots here. They're each going to start with a decimal point. So really you can put that 112 anywhere. And then your 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All your digits go underneath there. I'll just write the 0 and the 1. So you get to put where you want to put your 112. You can put it there if you wanted to. You can even put it up front if you wanted to. As long as you just keep it together, you're good.